Okay, let's see the behavior of soft soils, and we can determine the strength using what's called as a Vane shear apparatus. Vane shear is a simple device. You have a rod with two blades. We call them vanes. One is in the one direction, other is perpendicular to it. Look at the plan. This is one vane, this is another vane. And you have a handle here. I can rotate it by applying force so that you get a torque. So you get a torque. You can put a torque spring to measure it, or if I know P and the lever arm, I can find out the torque is equal to P into 2A, where A is the radial distance. So you can measure the torque and find out how much force do I need or moment I need to rotate inside the ground. The actual equipment in the field looks like this. This is called a torque wrench. You have a collar, you have a thrust bearing, you have a guide so that it will keep going vertical, and you don't want it to be inclined. And then here is the rod that goes inside the ground, and the vane is below the bottom of the hole. If the bottom of the hole is here, you should push it at least 1 to 2 diameters so that the soil here is undisturbed. And here is the ground level. You can make hole at different depths and push the vane and do the vane test. So this is the in situ vane shear device. These are all the bearings that we have, and when you rotate it, what you will get is a cylinder. Please remember, this is one vane, another vane, and you are rotating. So the cylinder is formed here of height h and diameter d, and you will have undrained strength mobilized along the cylindrical surface, along the top and the bottom surface. So perform at the bottom of the boring by pushing the vane below that. It's a four-sided blade pushed into the soil or silt, clay, etc. We determine the peak undrained strength and the remolded one. Peak is when I test it in the first instance, what is the maximum strength I get. When I rotate it about 5 to 10 times, I am completely destroying the structure, in which case you get remolded strength. The ratio of these two is called sensitivity. It's equal to undrained strength at peak divided by undrained strength for the remolded value. And this is the schematic of the test. Here is the borehole. You put the vane, push it inside to sufficiently deep depth so that the disturbance due to boring is removed. Apply torque here, rotate it, you determine the peak value. And then now you rotate 3-4 times or maybe 10 times, you get the remolded strength, and you will get the residual strength. And as I said, the equation is generally somewhere around 6t by 7 pi d cube if I am using h by d is equal to 2. From that equation you can easily find the undrained strength is equal to 6 times the torque by 7 pi d cube. And if I do the test, peak and residual, you get the sensitivity. This is how we write torque is equal to C undrained strength pi d square, the parameter lambda, h by 2 d by 6, and lambda takes care of the mobilized strength. It's also a function of the plasticity index because of the speed at which we rotate. If I now plot vane strength with depth, I can do the test set different depths, 5 meters or 6 meters, 7, 8, etc. We also determine the residual strength. If you take the ratio, you will find that the sensitivity in the top 20 meters is around 3, but if you go deeper, sensitivity is more. It's something like 4. So advantages of vane test are you can get shear strength of clays very easily. It's a very simple test. You are measuring in the ground. You don't have to bring it to the laboratory, and it has been used for quite some time. Now, what are the disadvantages? You can use it only for soft to stiff but not very hard soils. You cannot use it for sands, and the strength has to be less than 200 kilopascal. It's a very slow and time consuming because you have to make a hole, push the vane, etc. And you need some correction for various factors that are affected. And it can also be affected by, in nature, the clay may have some sand. If it has sand, the Cu value we measure may not be very good. And also it depends on the how old the clay is. Suppose it's a recently deposited. When I say recent, it's a geologic recent. For a geologist, anything less than 1 million years is called recent. There are some soils which have been deposited in the last 20, 30, 40,000 years. They behave like young clays. Those that have been deposited maybe about 1 million years back, we call them aged. And this is how the Cu by effective stress varies. So we need to also find out. It's also a function of plasticity in terms of the over-consolidation ratio also. And the other one is, as I said, we are doing the Vane test in a very, very short period of time. Time to failure in a Vane test is less than 10 minutes, whereas in the lab or in the field it may take maybe 1 hour, 100 hours, 1000 hours, etc. So it's very rate sensitive, and we need to correct for when you are constructing an embankment. I'm building on a soft clay. I may take 1 year, 2 years, in which case the rate of loading is low and I get a much smaller factor. So we correct for that. So we need to correct Vane shear strength to take care of the speed.